Imagine walking into your home after a long, exhausting day in the sweltering summer heat. You're looking forward to nothing more than the crisp, cool embrace of your air conditioning. But as you walk across the hallway, you hear a strange sound. A rhythmic, persistent drip, drip, drip. You look down, and your heart sinks. There is a growing puddle of water right in the middle of your floor, or worse, a dark, damp stain spreading across your ceiling. Your air conditioner, the very thing meant to provide comfort, is now threatening your home with water damage. Why is this happening? Is your unit broken beyond repair, or is it something simple? Today, we are going to pull back the curtain on the inner workings of your cooling system to solve the mystery of the indoor leak. We'll explore the physics of condensation, the mechanical failures that lead to overflows, and the simple maintenance steps that can save you thousands of dollars in repairs. Whether you have a standard split system or a high-tech WindFree unit, this is the ultimate guide to keeping the water outside where it belongs. To understand why an air conditioner leaks, we first have to understand what an air conditioner actually does. Most people think of an AC as a machine that makes coldness, but in the world of physics, cold isn't something you create. It is simply the absence of heat. Your air conditioner is actually a heat mover. It takes the heat from inside your home and dumps it outside. However, in the process of moving that heat, it performs a second, equally important job. It removes humidity. Think about a cold glass of iced tea on a humid summer day. Within minutes, beads of water form on the outside of the glass. That water didn't leak through the glass, it came from the air. This is called condensation. When warm, moist air hits a cold surface, it reaches its dew point, and the gaseous water vapor turns into liquid water. Inside your air conditioner, there is a component called the evaporator coil. This coil is filled with very cold refrigerant. As your furnace blower or air handler pushes warm house air over these cold coils, two things happen. The air gets cooler, and the moisture in that air turns into liquid water. This moisture is supposed to drip off the coils into a pan and flow out a pipe. But when the delicate balance of airflow, temperature, and drainage is disrupted, that water ends up on your floor. The most common reason for an indoor leak is a clogged condensate drain line. This is the primary exit ramp for the water collected by your AC. Over time, the environment inside your drain line becomes the perfect breeding ground for trouble. Because the line is dark, damp, and warm, it attracts algae, mold, and various types of fungi. These organisms grow into a thick, jelly-like sludge. Additionally, dust and dander that manage to bypass your air filter get caught in the wet coils and eventually wash down into the drain. Over several seasons, this mixture of biological growth and household dust creates a stubborn clog that acts like a cork in a bottle. When the water can't flow out the pipe to the exterior of your home, it backs up into the internal drain pan. Once that pan fills to the brim, it overflows, leading to the puddles you see on the floor. In many modern systems, there is a safety device called a float switch. If the water backs up, it lifts a small plastic float that trips a switch, instantly cutting power to your AC. If your AC suddenly refuses to turn on during a hot day, a clogged drain line is often the silent culprit. The second major cause of leaks is actually much more dramatic: frozen evaporator coils. It sounds counterintuitive that a block of ice could cause a water leak, but the physics are straightforward. Under normal conditions, the evaporator coil stays just above freezing. However, if the system's equilibrium is disrupted, the temperature of the coil can plummet. As the moisture from the air hits the sub-freezing coil, it doesn't just condense, it freezes solid. Over several hours, your air conditioner can transform into a literal block of ice. The leak happens during the Great Thaw. When the unit cycles off, that massive amount of ice begins to melt all at once. This sudden deluge of water is far more than the narrow drain line and shallow pan were ever designed to handle. The water rushes over the sides of the pan, bypassing the drainage system entirely. Why would a coil freeze? It usually comes down to airflow or refrigerant. If your air filter is filthy, the air can't get through. Without that warm air to warm the coils, they drop below 32 degrees. Similarly, if your system is low on refrigerant, the pressure inside the coils drops, which paradoxically causes the remaining refrigerant to get much colder than it's supposed to. Now, let's talk about a very specific and modern issue that often baffles homeowners with high-end units, like the Samsung WindFree series. You might find that your AC leaks after running for an entire day, but then mysteriously fixes itself after you turn it off for a few hours. This is rarely a clog. It's usually a phenomenon called fascia condensation. In specialized modes where the AC uses microholes to disperse air without a direct blast, the air velocity is very low. If your room is particularly humid, perhaps it's raining outside, or you've been cooking, that heavy, moisture-laden air hits the freezing cold plastic face of the unit. Because the air isn't moving fast enough to sweep the moisture away, the plastic panel itself drops below the dew point. Water begins to form directly on the front of the AC. Eventually, these droplets join together and start dripping off the front of the unit onto the floor. When you turn the AC off, the plastic panel warms up, and the ice or moisture has time to evaporate or drain away naturally. To prevent this, technicians often recommend increasing the fan speed or using the dry mode for an hour to pull the humidity out of the room before switching to the ultra-quiet, low airflow modes. There is another hidden cause that many people overlook: the cleanliness of the coils themselves. The evaporator coils are covered in thousands of tiny aluminum fins. These fins are designed with a specific surface tension to help water sheet downward into the drain pan. When the coils get covered in a light layer of oil, hairspray, or cooking grease, that surface tension changes. Instead of the water flowing smoothly down the fins, it begins to bridge across them or bounce off. This can cause water to spray off the coil and land outside of the drain pan. If you see small drips coming from the air vents rather than a steady leak from the bottom, your coils might just need a professional cleaning with a specialized degreaser. We also have to look at the catch basin itself, the drain pan. In older systems, these pans were often made of galvanized metal. After years of constant exposure to moisture, these metal pans can develop rust. Eventually, that rust eats all the way through the bottom of the pan, creating pinholes. You might have a perfectly clear drain line, but if the bucket catching the water has a hole in it, the water will drip straight through. In some homes, the AC is located in a basement or a spot where gravity can't do the work of draining the water. In these cases, your system uses a condensate pump. This is a small reservoir with a motorized pump that kicks in once the water reaches a certain level. Like any mechanical device, these pumps can fail. The motor can burn out or the internal float can get stuck. When the pump stops working, the reservoir overflows and you end up with a flooded floor. An air conditioner must be installed with a very specific, though slight, pitch or tilt. The internal drain pan is designed so that the floor of the pan slopes toward the drain hole. If the unit isn't level, or if the house is settled, the unit might be tilted away from the drain. The water pools in the low corner of the pan until it spills over the edge. Furthermore, we shouldn't overlook the pipes themselves. The copper refrigerant lines are extremely cold and must be wrapped in thick insulation. If this insulation is missing or torn, the cold copper is exposed to the humid air. Just like our iced tea glass, these pipes will start to sweat. This condensation can happen all along the length of the pipe, causing water to drip onto your drywall or flooring in places far away from the actual AC unit. While a leak might seem like a minor annoyance, the consequences of ignoring it are significant. Stagnant water contributes to the growth of mold and mildew, which can then be blown through your ductwork. Moreover, water and electricity are a dangerous combination. A leak can drip onto sensitive circuit boards, leading to short circuits. The good news is that most of these issues are preventable. 1. Clean or change your air filter every 30 to 90 days to ensure proper airflow. Flush your drain line twice a year with a cup of white vinegar to kill algae. 3. Keep an eye on humidity. If you live in a tropical climate, run your AC at a slightly higher fan speed to prevent fascia sweating. In conclusion, your air conditioner is a complex machine that manages heat, air, and water all at once. When it leaks, it isn't just breaking. It is telling you that its internal balance has been disrupted. Whether it's a simple clog, a frozen coil, or the unique condensation challenges of a WindFree system, understanding the why behind the water is the first step toward a dry home. By staying on top of your maintenance and listening to the warning signs your system gives you, you can keep the water where it belongs, outside and out of mind. I am Saul. Thank you for joining me on this deep dive into the mechanics of home comfort. Keep your filters clean, your lines clear, and stay cool.